Hello, mathematicians. Today's lesson is on changing mixed numbers to improper fractions. There's a lot of language just in that little statement, so we're going to go over a few definitions really quickly. Those three things are proper fraction, improper fraction, and mixed number. So let's start with proper fraction. So proper means that your fraction has a numerator or a top that is smaller than the denominator or the bottom. Improper fraction is the exact opposite of that. To be improper, the top must be larger than the bottom. And finally, a mixed number. Every mixed number, like for example, 3 and 2/3, will have a whole number in the front, followed by a proper fraction. Whole number, proper fraction. So those are three quick definitions. One other thing I'm going to tell you before we do an example is in math, when you put a dot, just a solid dot like that between two numbers, like let's say 5 and 2, that dot means multiply. 5 times 2 equals 10. So instead of using the sort of like the X looking time sign, 5 times 2 equals 10, from here on out, we're going to use the dot. And I'll show you why when we do our first example. Okay, so our first example is we are going to take the mixed number 3 and 4/5, and we're going to transform it into an improper fraction. So it's super easy to do. All you do is take the 5, take the bottom of your proper fraction, and multiply that number to the whole. Notice how I'm using the dot. I'm using the time sign. You'll see why in a second. So 5 times 3, let's do that in our heads, is 15. Now hold on to that. Hold on to 15, and now add 4. 15 plus 4 equals 19. And then you put that on top of this denominator, 5. And that's how you change a mixed number to an improper fraction. So why did I use the dot? Well, if I use an X for a time sign, depending on the way you may turn that, it could look like a plus sign, and I don't want to confuse it. So times these two, take that product, add the top, 19 over 5. Let's do another one. Let's do 5 and 2/9. Let's transform that to an improper fraction. Do you remember the steps? We're going to take 9 times 5, hold on to that, 45, plus 2. 45 plus 2 is 47, and we're going to put that all over the denominator. So maybe an easy way to remember what the denominator will be is whatever the denominator was here in your proper fraction, it will just carry over to the improper fraction. And that's really all there is to it. Now, I do want to leave you with one thing. You might be thinking, why do you do what you do? Why do you multiply and then add? Well, it's kind of cool. So you see how your proper fraction has a 5 as its denominator? Well, if we take the whole number 3, we can get to that 3 by adding 3 versions of one whole together using the 5 as our denominator. Let me explain. So say we add 5/5, which is one whole, plus another 5/5, which is another whole, plus one more 5/5. So basically 1 plus 1 plus 1, and I can even write that under there, 1 plus 1 plus 1. That will be our 3. And then in addition to 3, we have to add part of a whole, which is this part. It's not quite 5/5, but it's 4/5. And when you add all of those fractions together, let's see what we get. Well, 5/5 plus 5/5 plus 5/5 plus 4/5. We know we add the numerators. So 5 plus 5 is 10, 10 plus 5 is 15, and 15 plus 4 is 19. And when we add fractions, we just keep the denominator. Now let's review. When you do the shortcut, you take 5 times 3. That's this part. You have 3 5s. And then you add the part, you add the 4, and that gives you the 19. So instead of doing it this longer way each and every time, we do the shortcut. But that's the reason why we do it. Okay, everybody, thanks for watching, and happy trails to you.